Alrighty, so what we have here is the front end of the UPLC extraction. We're going to need 3 test tubes, mortar and pestle, spatula, our 0.3 grams of plant tissue, a waste beaker with sodium bicarb, 5% perchloric acid, ultra pure water, as opposed for this video, just because I'm trying to be safe and I want to show you how to do it. So we're going to transfer our plant tissue into our mortar and pestle, and then we're going to grind it up pretty thoroughly. I like to do it without any additional liquid at first. So yeah, we're going to get here, crush up all the large chunks and that sort of thing, and then we'll add 5 milliliters of perchloric acid where needed. This tissue isn't frozen, but as you can see, it's still doing some good work for us. Yeah, so you're going to get some stuck on the pestle. I'm going to take 5 mils of your perchloric acid. So we're going to crush it some more. You're going to spin it one way, stop maybe suddenly, and go the other way. You kind of have to figure out what works for you. So you can see with it comes off the pestle pretty nicely. And you remember, you want to be wearing PP for all of this. I'm just using water for the sake of video, and I can record and touch my phone and that sort of thing. So you're going to take a spatula if it gets stuck on the sides and push it down. And if there's any stuck on the spatula, make sure you dip it in until tissue comes off the spatula itself. So yeah, it's kind of tedious to get that off, but that's pretty good. You're going to set that aside. I like to set it in the weighing boat that you used, because some of it will drip off, and then you're going to pour some of that back into the mortar and pestle. Okay, so you're going to open up your tube, and what you need to do is pour really quickly. It takes a lot, a little bit of practice and precision. One thing too is to make sure that you're scraping down the sides with the spatula. I almost forgot to do that here, but you take the plant tissue, push it into the solution. Make sure you get everything, and you should be very thorough about this. And here, for demonstration purposes, I was just going a little quicker. And this plant tissue is acting all weird. It was getting stuck to the mortar, but just take your time to go around and really scrape everything into solution. And this is only 3 mils of perchloric. We're going to use the last 2 mils to rinse out the remaining. And this is more than enough tissue. This was actually closer to 0.5 grams. I just wanted to show you that it's possible to get all the plant tissue in, even with a lot of it. Okay, you're going to pour pretty quickly, and you'll see like a lot of the plant tissue doesn't get in. So we're going to add our last 2 mils or so. We want about 5 for the first spin. And you can measure that out using a 10. I would recommend using a 10 milliliter graduated cylinder. And so yeah, see, there's that drop from the pestle. You're just going to put that back in solution, because that's, a good amount of your analate just like sitting on your pestle. Okay, then you're going to pour off quickly. And if any remaining tissue you don't get, you can pour back from the tube, but also you can just use the spatula for transfer. Okay, so we're rinsing here, just cleaning up this sample, and what I do is I just use ultra pure water to rinse out, and then you pour it into a waste beaker with sodium bicarb. It's perchloric acid, so you're going to need a lot of sodium bicarb. Just remember, for the sake of this video, I used water as opposed to actual perchloric acid, so you want your PP, splash goggles, gloves, that sort of thing. And so yeah, you're going to rinse the pestle too, and the spatula. You can set it aside. You'll want to wipe it dry later, and then you can also rinse the weighing boat to be reused again. Okay, you're going to wipe it dry, make sure you have gloves on, and you'll toss it in the trash. Alright, this is how we balance the centrifuge tubes on the scale so the centrifuge doesn't blow itself up. So we're just going to take this analytical balance, make sure it's in the circle here as well, and then you're just going to tare it, and then throw your sample from a plant extract on here, Reads 16.2627, and you can just pop your cap and thing in here, and then we're gonna get to that 16.27 just by filling up with water here. Okay, pretty close. But that's pretty close there, so 16.23 if you round up is definitely more than close enough. Take the cap out and then screw it on, and then these are approximately the same weight. Okay, for the centrifuge, you're going to turn it on to actually open it. Open this lid, make sure you don't slam it. We're aiming for a speed of approximately, where am I? 12,000 Gs, so we want to spin at 10,000. And what I've been using is this marker as opposed to this, so that's why this speed is slightly off, because to get to 10,000 you need to have this dial turn, so I don't think that's calibrated, or maybe it's the other way around. But in any case, you open this sucker up, and this is your rotor. This thing can rip your arm off if it wanted to. That's why we close the lid and it locks. But you're gonna put these apart in opposite things in one of the adapters here. So these tubes aren't meant for going up to that many G's, so they might bulge, they might crack, they might break. So best of luck. These are all we have to work with right now, and so hopefully in the future we can get something better. But you know, they're conical at the bottom as opposed to rounded, and these adapters are rounded, so there's a lot of pressure on that tip. Okay, you're gonna put it in, hold it so it doesn't slam, and then you're gonna set it to 30 minutes for the first spin, and then click start. I like to sit here and make sure the rotor isn't gonna destroy itself. It shakes a little bit at first, but then once you get up to 10,000, you can tell because it's just smooth sailing. So we're just gonna watch it here. Also, one thing to look at is the rotor temp. If that isn't around, room temp or maybe a little hotter, then you should probably seek some help to get that fixed. I don't think your rotor should be much hotter than 25 C or so. Okay, here we go, it's coming up. Alrighty, and that's about, that's not many dials on this. It's more like 11, but on the RPM meter, it doesn't, that's about 10,000. And so we're getting our 20 or 12,000 Gs, and we're just gonna let this run for 30 minutes. Okay, what we have here is the result of our first spin. There's our pellet with our plant tissue and the supernatant. And we're going to essentially pour off the supernatant into the second tube. The third tube is not useful for us at the moment, so we're going to take off the caps. And you're going to pipette very carefully off with a plastic pipette. I'm kind of doing a bad job here because I can't see, because I set myself up for failure. I put the tape right in front, and I'm also doing this with one hand and holding my phone and that sort of thing. So so I transfer this over. You want to get as much of the supernatant off as possible. This is where you can lose the most analyte from your sample. And so you're going to get about, you're picking off about 5 mils, and so you're going to transfer those as close to 5 mils as possible. It's okay to get some plant tissue in there. You definitely want to avoid a lot, but this is okay. There's some floaters in there and that sort of thing. Okay, you're going to spin this off, and there you go. So you have your pellet. You're going to vortex it. I do it a little early here, but I'm just testing if it's on. Which it's not. Of course it's not. Alright, there you go. Look, see. Ready to go. But you're going to open that, add exactly 5 mils using a graduated cylinder. The first spin didn't really matter all that much. You just want about 10 mils because in total, once you pH adjust it, you need it less than 15 for the tubes, for it to fit in the tubes. Okay, let's say that was a perfect 5 mils. You're going to pour that in, put the cap back on, and then vortex it for 10 seconds before throwing it back into the centrifuge for an additional 30 minutes. This just helps the perchloric get around, interact with the compounds in solution. We have our supernatant after the second spin. We need to pH adjust it to allow it to fit within the limitations of our column, but then also to precipitate out the perchloric. Okay, so here's our supernatant. Here's our third test tube. Okay, 25 mil flask for later, volumetric. Okay, we're going to take off, and this, for example, this is all water being used in here. You definitely want PPE. You need to be working in a fume hood. You're spinning a bunch of 5% perchloric acid, which sits at about 0.5 pH, which could just damage, any part of you, especially your eyes. So be careful. You're gonna get a tiny stir bar in a 20 milliliter beaker with a pH probe in it, definitely calibrated, and then you have your 0.0008 potassium carbonate solution. I found this to be pretty good. It keeps you under the 15 mils, but you're able to pH adjust it. And so essentially, you'll want to use the glass pasteur pipette so you can get better drops and predictable drops. I just used the water and plastic here just for demonstration purposes. Okay, you're going to take it out when it's ready, when it's at that pH adjusted to 2. You're going to pour off into your third test tube, and there's going to be some droplets of perchlorate in solution. You can let one, just pour it all out because we're centrifuging it again. And so, right, so we're going to centrifuge at 12,000 Gs for 10 minutes, and then fortunately the pellet actually pelletizes, and you can just pour off into the volumetric flask and bring it up to 25 mils, and then flip it a few times, and that's your extraction. Okay, so we are going to filter our mobile phase for the UPLC. The filter that we want is in this membrane filters drawer. It's specifically this membrane filter. The reason being is Tanya suggested this because it's compatible with certain components and a pH level. So we're going to come over here. We have a collection flask here for the vacuum filtration setup so it doesn't just go into the vacuum. And then these are the components we need. This little glass thing, this glass filter as well. It's our mobile phase, which for demonstration, I'm just using DI water, and then this flask as well, and then this clamp. Just to mention, we don't want to use any soap on these, just rinse with DI water pretty strongly because soap can mess with the column in the UPLC, and so we don't want to fiddle with that. Okay, so essentially we're going to set this up here. We're going to pop open the filters. And you should be having gloves wearing this, but I'm just dealing with water, so it's okay. There we go. Okay. This blue paper, which isn't very blue on camera, but that's just a separator for the filters, and your actual filter is this white paper here. And so you're going to set it up on the glass here. Put this thing on here, and you're going to clamp it down. Right. There we go. And that's good. There we go. And make sure this is pushed in, that way it's not slipping off. Okay. Next thing we'll do, we'll put this back on here and we can set that to the side. We're going to get our vacuum tube here and connect it to our flask. And so we go. It's connected. And this is what the setup looks like inside in case it gets shifted around. Okay. Now we're gonna turn the vacuum about a full turn around or a few. We're gonna take our mobile phase, which remember this is just water, so you should be wearing goggles and PPE because vacuum can splash. Okay, we take our water or our mobile phase and we're gonna put it in here, all of it. And it's gonna start to filter rather, into our flask. And Tanya hasn't had any problem, this was her advice, but we're just gonna pour this back into here. Essentially, the filter here is to either filter out any organisms if your mobile phase is kind of old, and if it's in water specifically, despite it being at a low pH, it's gonna still grow some bacteria over time. So we can get rid of that using this filter. Additionally, we just want to get rid of any solids that may be in here because they can precipitate out into, if they're not dissolved in that mobile phase, they're gonna precipitate out into here, and the column's very small. For example, they look like this. That's a lot of pressure, and that would totally damage our column. So in the meantime, also, this is the sample loader. Essentially, you're gonna put in this because usually the second pump we're never gonna use because there's usually enough space here, but sometimes you might need to use this. But in any case, you can essentially just take out the blue thing if you want, and then just load the samples that way. And this translates to the numbers listed on the plate/well column. So 1A, 2A, 3A, and so on. And then the best way to put this in is sort of lead that right-hand corner back there in, and then push down on the left-hand side. You can also slide this out, but it doesn't go very far, so it's kind of a redundant little engineering feat. And then you'll close that, and it's kind of like a fridge door, so you'll know when it's closed. Okay, so our water is almost filtered completely. It takes its time, but it's not a very long process. And so we're gonna let this go all the way. Okay, there we go. So now that it's practically all through, which it is now, and this stops leaking, you can turn the handle all the way to the right, and then you want to break the seal, the vacuum seal here. With the rubber tube. Okay. Now that the seal's broken, we can disassemble this whole thing, being careful not to knock over everything. It'd be nice to have two hands, but I don't right now. Okay, so you're just gonna take this filter off, throw it in the trash. You'd likely want your PPE for that step specifically, and then you're gonna set this on here. That's kind of how I do it just for now. And then we're gonna pour our mobile phase back into the original container, and then you're set to go. Another thing too is make sure you label when you made this and when you filtered it. That way you're not throwing some old mobile phase in. Okay, now we're going to put it here to install, I guess, your mobile phase. Essentially what you're gonna do is put it up here. This is old mobile phase. We'll get rid of that appropriately. But essentially what we're gonna do, you wanna spin off the cap here, right? And then you're gonna replace this thing. If this is your mobile phase, that's solvent A1, and that relates to your solvent A1 that's mentioned in this here. So you can see solvent A and solvent B. Solvent A1, essentially you don't need to worry about cross-contamination or anything like that. That's not how it works. It'll get diluted. You'll put that in, rest it at the bottom. This is just water. I'm not gonna do that. And then we're gonna put it back in. You essentially want to, every time you swap, you're going to prime the lines. That way you're not getting
some contamination from your previous mobile phase or what have you, like your rinse phase.
Okay, I'm recording here on the Empower software for the UPLC. So here we need to make sure we have the right method set and instrument set uploaded. And then this is the run samples list. And I'll take you around and sort of define what are the important considerations. So what we need to do to start up the system is to open that little panel that I just clicked on, this little thing, the console. Okay, it's going to open, and then you're going to go System, see it's highlighted in the top left, and then you're going to click Control, and then Start Up System, Solvent Refresh if you used it, and then use last conditions if you previously used it. Use Custom, these are the settings that you want, 4 minutes, go on, 40, and then here's like your equilibration to bring it up to what you're running your samples at. So the flow, temp, and that sort of thing. You want your lamps on for the PDA, and then there's a summary of everything. And you're going to click Start and let it go. And then, boom. You want to let it run for an hour before actually running any samples for analytical work, and for your back pressure to be under 30. Okay, so you can add all these samples. You can add sample names. No. Here we go. In method set, this is where we're going to go in a second. Runtime, injection, delay, that sort of thing. We'll set that up in the end. Okay. So we're going to go to our method. We're going to open our spike method and see, look, we have 210. We have it processing at 210 nanometers, and you can set that to whatever you want. But that's what we have for here because that's what we want to measure at, and that's how we view our assets. Okay, then this is the solvent manager. These are just different panels on the left. Is related to each component of the UPLC, but this is our setup. So this is how we want everything to flow in our file. And so what we need to do is adjust. See that runtime needs to match the that binary solvent manager. So our runtime is 9.2 minutes. And then you can autofill everything down, which is nice, by right-clicking. And you can do that for any of the things. So see, you can autofill the method set here. But we're going to go back and look at the binary solvent manager. So we have it at 100% A, which is our mobile phase. And then we rinse with our mobile phase plus 20% methanol, or 80% our mobile phase and 20% methanol for a little bit, just to get out all of the things we don't care about that are in solution and need to be rinsed out quicker. And so we do that. We set it to 4-minute injection delay so that that back pressure can come down before the next sample starts. And this is all automating it. Okay, and then you can run, type in your sample set name, and like once you have everything in, then you're good to go. We found that injection volume of 2.3 was best. I don't type it in here, but you should make sure that's there, microliters. Okay. Let's say you run and then, something goes wrong, you can abort immediately if need be. Okay, so let's look at an example of what the data looks like. So we're just going to take, not this one, but this is what we just ran. See, it's aborted, there's no data, it didn't run anything. Integration, see, you can swap these parameters. Lift off is the peaks, minimum, maximum area of the peaks, end time, start time, peak width, detection threshold, that sort of thing. And then you have to click integrate after doing all that. And so let's go to an actual project that we did for some data. We're going to replace so we can see our things. So here, this is what a UPLC thing looks like. Here's all of our different standards. And we don't want it to integrate. See, that's the solvent front. We don't want it to integrate some of those peaks. We only want that last peak because that's our citric acid. These other peaks are just impurities of our things or what have you. But you can delete those, and then there you go. it's going to just keep that one peak in there integrated. And so one thing to notice is that, look, here are our settings, minimum area of 50, maximum height of 50, and I think that's in units of AU. And then that 2.00 to the minus 01 is just the width, or the base size. And then if you click integrate again, it's going to reintegrate all those peaks. But these are the settings we use for integration: automatic 10, 10, 50,